Every year, the United States is hit by more tornadoes than any other country on Earth. Not by a small margin. The US gets roughly 10 times more tornadoes than the rest of the world combined, and almost all of them strike the same general region. A stretch of land running through Texas, Oklahoma, Kansas, Nebraska, and South Dakota. A region given a name back in 1952 by two Air Force weather officers tasked with something no one had ever done before: forecasting tornadoes. They called it Tornado Alley. But why here? Why does this specific strip of land get hit again and again while almost nowhere else on the planet experiences anything like it? The answer comes down to geography, and it's more unique than you might think. To understand Tornado Alley, you need to understand what a tornado actually needs to form. Tornadoes are born from supercells, massive rotating thunderstorms that form when very different air masses collide. And Tornado Alley sits in exactly the spot where two very different air masses are almost guaranteed to meet. To the south is the Gulf of Mexico, a massive warm body of water constantly pumping warm, moist air northward into the central United States. To the west are the Rocky Mountains, a huge mountain range that pushes cool, dry air down across the plains. When that warm, moist Gulf air slides underneath the cool, dry mountain air, you get instability. The warm air wants to rise, the cold air wants to sink, and when they collide with enough force, that's when the atmosphere becomes a pressure cooker. This collision is the engine of Tornado Alley, and it happens here more than almost anywhere else on Earth because nowhere else has this exact geographic setup. A warm ocean to the south, a major mountain range to the west, and flat, open land in between with nothing to slow the air masses down. That last part matters more than people realize. The Great Plains are remarkably flat. There's nothing to break up or slow down these colliding air masses before they crash into each other. No mountain ranges in the middle, no major forests, just thousands of miles of open land. This flatness lets warm Gulf air travel hundreds of miles inland without losing its energy. It lets cold mountain air spill eastward without being disrupted. When these air masses finally meet, usually somewhere over Texas, Oklahoma, or Kansas, they meet at full strength. Nothing has slowed them down. The result is wind shear, winds blowing at different speeds and directions at different altitudes. And wind shear is the second key ingredient for tornado formation. It's what causes a storm to start rotating instead of just rising straight up. There's also a seasonal element to all of this. In spring, the temperature contrast between the Gulf of Mexico and the northern plains is at its most extreme. The Gulf is warming up fast, but cold air is still spilling down from Canada and the Rockies. That's why tornado season in Tornado Alley peaks in the spring, typically April, May, and into June. This is when the collision between warm and cold air masses is at its sharpest. There's also often a secondary peak in the fall, especially in the region sometimes called Dixie Alley, parts of the southeastern United States, where similar temperature contrasts return as summer fades into autumn. So here's the question that actually fascinates meteorologists. Tornadoes happen on every continent except Antarctica, but nowhere comes close to Tornado Alley. There's actually one place on Earth with a strikingly similar setup, a region in South America near Argentina and Uruguay, with a warm ocean to one side and the Andes Mountains to the other. On paper, it looks like it should produce tornadoes at a similar rate, but it doesn't, not even close. Why? Scientists are still researching the exact reasons, but the leading theories point to subtle differences in the orientation of the mountain ranges, the angle at which air masses collide, and differences in how the jet stream interacts with the land in each region. It turns out that getting the ingredients right, warm ocean, mountains, flat land, isn't quite enough. The geometry has to be almost exactly right too, and the central United States happens to have, by sheer geographic luck, close to the perfect geometry for tornado formation. All of this might sound like trivia, but it has real consequences. Because Tornado Alley isn't just a weather pattern, it's home to millions of people. Major cities like Oklahoma City, Wichita, and Dallas-Fort Worth sit directly inside this zone. The same geography that makes this region one of the most productive farming areas in the world, flat land, fertile soil, and access to water, is the same geography that makes it one of the most tornado-prone places on the planet. People who live here grow up with storm shelters, weather radios, and tornado drills as routine as fire drills.